Hi everybody, it's Austin JavaScript.
Hi.
This is our comedy routine part of the evening.
It's really good to see all of you folks tonight. Welcome.
Who are you?
Why are you here?
I'm Aaron. I've been gone for a couple months.
The Java guy. Yes.
Yes.
Y'all remember that?
I put the Java. I feel like I just got read. I put the Java in JavaScript. Here, welcome. I've been gone for a couple months, but I'm back.
Yeah.
I don't know if I'd say it's good to be back, but I'm back. But we're really excited tonight. We've got a really exciting speaker that, and I said this to him directly just moments ago, that is, I think, in all of the awesome JavaScripts we've ever had, the most probably high maintenance that we have ever had. And I mean
it's a bad idea.
Very genuinely.
Is that like an audio board?
Yeah, there's like all this stuff.
That's real
Made
stuff.
bad choices in life.
So we're really excited to make beeps and boops with JCal here soon. Before we get into that, we want to thank everybody that makes this possible. And I don't know who that is, so.
We just
Because I just walked up.
Thank you, first of all, Spreadfast for being our wonderful host. We really appreciate their help with that. And if you had some pizza or drink some beer or drink some soda, we can thank Michael Norman from Irrelevance. He's going to tell us a little something about what they do or not. Well, we'll do the code of conduct now.
Oh, we'll do that, yeah.
Sweet. Hello. So I paid for the food, right? So we are at Irrelevance. We're hiring right now, which is one of the reasons why I'm out, beating the streets and recruiting as much as I possibly can. You might have seen us at the Startup Crawl. We are a startup here in town. We have about 50 employees, but a very, very small engineering team, about 5 engineers. And what we do is we're a technology-enabled marketing agency, which you're like, developers, why do I care about marketing agency? But we built our entire marketing platform from the ground up, completely from scratch. And we do multi-channel marketing, make it really easy for our clients. And we're doing it in a way that is effectively at SaaS scale. So think the margins that you would get from SaaS. And so from a market perspective, we can go after a lot smaller companies and actually get thousands of them as opposed to just having hundreds of clients or tens of clients that most marketing agencies can. So that's what we do. It's a little bit, in a nutshell. I don't want to spend too much time here because this is going to be a much cooler talk than I can do. But if you want to, after whatever, at Benjamin, catch me, chat about what we do. So thanks.
So most importantly, the thing that we've had up back here is the code of conduct. This is a formalization of the great culture that we have here at Austin.js. The TLDR is to be excellent to each other. And if anybody sees anything short of that, please contact one of the organizers that's actually organizing tonight, which is Lon and Rebecca.
Yeah, we literally took your name off.
Yes. Yes. Please contact one of these folks or me. You guys know.
Y'all can reach us by these email addresses. Or on Slack, you can Slack us on
Slack. We have a Slack.
Yeah, we have a Slack.
What's that called?
It's been automated, so you can
You can log in to our website. Yeah.
We'll
Go to the website, click the thing.
tell you about that after it would be useful. After JCal's done talking, we'll remember how you sign up for that.
But if y'all want to do like party parrots during the talk, you can go to the website and click the link and it'll happen somehow.
So I don't remember. It's not. I don't remember anything. I sent out the thing with Meetup.
And you can also,
Go to meetup.com. I think maybe there's something there about the Slack. I don't know.
We're highly organized. You can also, if you need to get a hold of us, you can DM
us
Austin JS or Loncy
Or R. Murphy.
Or Murphy. All right.
All right.
With no further ado.
Hi, welcome to a talk about Web Audio API. Is there any first time Austin JavaScript folks out there? Or are y'all regulars? A few of our first timers. Most of the time, the talks around here are more practical than this. Like you can, like last month, I learned how to use source maps and took it back to my day job the next day. If you can take this back to your day job, like feel free, add some bleeps and bloops to your web app. Check with your product team first, maybe, but you do you. Also, I'm going to apologize for my gesticulating up here. I talk with my hands, and my mental state is somewhere between coming off Benadryl and over-caffeinating and having an IPA. So see how it goes. My name is Kyle Fagan. The J is mostly silent, but if you want to find me online, at jkyle is my social medias. I don't tweet a lot, but if you want to talk about music or code or comic books, happy to chat. Instagram is pictures of drawings I do because I don't have enough hobbies. I want to be an artist also. And then GitHub, the slides and the code will be up there fairly soon. I'm a JavaScript developer. I write JavaScript for a company called Eduphoria. We work just a couple blocks in one of these directions. We have a really great team of JavaScript developers that I lead. Somewhere in my job title is architect, which you can tell because when I decided to give a talk, this is the system I've engineered. There are like so many points of failure up here. We're just going to go with the flow tonight. We're going to keep it kind of chill. At Eduphoria, we write tools for teachers and school districts. And we're really proud of what we do. Our goal is to make educators' lives better. We make tools to help them get some of the bureaucratic stuff out of the way and focus on stuff that they care about, like educating our students. We have about 85 to 90% of school districts in Texas use at least one of the products in our suite, which is great. It means that a lot of us at Eduphoria either have been educators or we have personal relationships with educators. So it makes a difference because like this woman right here, she's a great lady. That's my mom. She teaches high school science stuff back in my hometown near Fort Worth, and she uses Eduphoria. So we judge code quality based on how many text messages and emails I get from my mom after a release. If you've never gotten an email like this, let me just say this is a way more powerful motivator than any code review or testing suite that might run. So I've been writing JavaScript for probably eight years, coding a little longer than that. I think the first time I really dove into JavaScript was jQuery Conf 2009, where I saw our very own Rebecca Murphy give a talk about organizing your code with objects. And in my 2009 brain, that was just like, what? This was before module loaders and stuff. So that's when I really dove in. And now I'm at Eduphoria. It's great. You might be wondering, though, am I qualified to give a talk about music and audio technology? You tell me. DJ JK. One time in 2011, I DJ'd a party. It's like the extent of my musical experience. Growing up, I never took music lessons. I always thought like guitar was for people who knew how to play the guitar. I missed the whole bit about practice. So when I should have been in a Weezer cover band when I was 15, I was programming games on my TI-82. Some of y'all have been there, right? But as I got older, I got into synthesizers because music is still a big part of my life, and I wanted to be involved somehow. And I'm kind of a sucker for like clicky knobs and flashy lights. So I started spending disposable income on this stuff that I don't really know how to use. But like only one of those things has a keyboard on it, so I thought I could learn how to do these. It's just knobs. Turns out, not true. You still have to know what you're doing. You still have to practice and understand how to make music with it. But I learned a lot about synthesizers. We're going to learn about synthesizers tonight. We're also going to learn about the Web Audio API and what you can use it for. So we're going to talk about what it is, about how does it work, what you can do with it, and whether you should use it. Spoiler alert, for that last question, the answer is like maybe. We'll talk about why though. We'll kind of wrap towards the end as we go. We'll see kind of where some of the limitations are. So what is it? The best way to think about the Web Audio API is by comparing it to the image tag and its relationship with the 2D context from the canvas tag, if anyone's used that before. So the image tag is great. I'd say it's probably one of the greatest of the HTML tags. It's one of the things we learn first when we start writing HTML. It's great if you have an image and you just want to render it out to the DOM. But what if you want to generate an image or manipulate an image? It's where you get into the 2D context. So the 2D context, it gives you a special API that's totally different from the DOM API for generating images at the pixel level, the bitmap level. Things just got really, okay, we're back. I thought we were gonna have a dance party. Like, we're ready. We can do it if that's what we're gonna. So it gives you pixel level tools for building bitmap images. The Web Audio context is very similar when you think about how it's related to the audio tag. The audio tag, I think it's fine. I haven't used it in the past couple years. I knew it used to be problematic, but if you have an audio file ready to go or a sound clip, you can drop it into the audio tag. You get kind of the DOM or the browser native controls for it, and you can play it back, stop it. But if you want to generate audio or manipulate audio, then you need a special API for doing that. And that's what the audio context gives us. Whereas the 2D context is sort of a pixel level thing, the base level for audio context would be kind of waves. We'll talk about waves. So how does it work? You end up building a graph of all these nodes that are super highly optimized for audio processing. As web app developers, a lot of us sort of get laser focused on trying to hit that 60 frames a second, butter smooth animation on our UI thread, which is important because if it drops below that, our eyes will sort of recognize that it's not a smooth motion. Audio is orders of magnitude more higher frequency than 60 frames a second. So the idea that we could process audio on our main UI thread is not reasonable. So what the Web Audio API gives us is specific nodes written in some low level like C or something, one of those, ++, and designed specifically for processing audio off the main thread, so you don't have to worry about it messing with your UI thread, and you get to generate waveforms from it. The Web Audio context has three main jobs. The first one is to give us the API for generating those nodes, and we'll talk about those in just a second. The next one is it gives us a destination, so all the audio that we build through our graph ends up at the destination node, and that's where it gets handed off to the system. So that's where your OS will pass it to the speakers or headphones, or if you make poor choices like I did, a PA system. It also gives us a very high resolution timer. Again, because of the frequency the audio has to be processed at, any gap, and we're talking like 1/44,000th of a second, most of our ears would be able to pick that up and recognize it as a discontinuous wave, and it sort of gives you a click or a pop. So this timer helps us schedule things, again, off the main thread so that it's a continuous waveform all the way through. So the nodes that you can create, there's three different types. If you count the destination as a node, you get source nodes. Those are responsible for generating the audio to begin with. That's like the oscillator nodes, which is what we'll talk about mostly tonight. You can also use audio buffers, which if you have samples to load, again, those would be like like waveforms that you've already got created, sound files. Or you could even use a microphone, so system audio type stuff to process audio real time. Then you pass it into effect nodes. Effect nodes' job is to manipulate those waveforms. We'll use a lot of the gain node. The gain node's job is to adjust the amplitude. And then finally, that goes off to the destination. So we're going to get into some coding. And like I said, lots of points of failure. So we'll see if this works out for us. All right. Let's open up. Y'all see that okay? All right, so the way you get your audio context is with this new window.audio context or some WebKit browsers, prefix WebKit. You use it to create nodes. So I'm just going to do a little bit of live coding, and then from here on out, it'll be mostly just uncommenting code. So the first thing we need is a gain node. The way you create that is with context.createGain. So that's our gain node. We're going to get an oscillator node, context.createOscillator. And we got to wire everything up. So you build that graph. So these are our nodes. Let's build the graph. So we'll connect the gain node to our context.destination. And then we'll connect our oscillator to the gain node. Okay. And then finally, we have to tell the oscillator to start playing. Now, I talked about the timeline that the audio context starts. As soon as it's creating it, as soon as the context gets created, it starts counting from 0. The units is in seconds. And so we use that to schedule the notes to play in the future. And so we'll use the start method, and we'll just say context.currentTime plus, let's give it a little 0.5. And then we'll tell it to stop. Like half a second later. All right. So in theory.
So the gain you mentioned is the thing that makes them like louder or quieter. What does the oscillator do?
So the oscillator is our source node. It's actually going to generate a waveform for us. So in theory, let's find
Can that
where
make things like higher or lower pitch?
it can, as a matter of fact. We'll find out very soon, actually. All right, so in theory, Webpack works, and when I save this, it'll refresh, and we'll hear something. Did y'all hear that? No, we need to turn this up. Is that a little loud? Let's turn it back down. See y'all. So that's the frequency you were talking about. The frequency that an oscillator defaults to is 440 hertz, which is middle A, but if you ask some people, it's a fake middle A, and the real middle A is 432 hertz. If y'all want to get into conspiracy theories, we can talk about that later. Defaults to 440 hertz, and the gain. So one thing you might notice is there's a little pop at the end. We'll get to that in a second. Let's do 2 boops. So we'll schedule it even further in the future. So we'll do 1.5 to 2. And you're like, oh, why isn't it playing 2 boops? And it's because it crashed on us. So this is one of the first things you run into when you start working with the Web Audio API. One of the first is that oscillators are totally disposable. As soon as you tell one to stop, it's done, and you can never start it again. Which I first thought, like, that sounds super wasteful, but apparently they're designed to be destroyed and created very, very quickly. So instead of doing this, basically what you have to do is create a little like play function that takes time, and then like all the work of creating it. And well, let's see, we got to create it, we got to connect it to the gain, we got to tell it to start and stop. Let's see, we'll do it relative to the time that we're passing in.
We just set the gain to 0 and reused it.
Yes. I don't know if it's better on memory. It probably is, because you only have 1 instead of however many. But again, it's optimized for doing it. The reason you might do that, though, is that, and when we get into like all this stuff over here, it's very hard to do monophonic synthesizer-y stuff if you're just creating oscillators left and right. So you have one going, and then you have different ways of controlling the gain for it. So yeah. So then now we can just call play a couple times. Play context.current time plus 1. Yeah. And then +2. Let's do +3. So this should. Cool. Right? Right? Thank y'all. So the other problem with oscillators is that little pop that we hear at the beginning and end, because of the way, again, most of our ears will process these waveforms. If there's a discontinuity, which is what happens sometimes if you kill a waveform when it's not like perfectly at 0, we sort of hear that pop. So the solution to that is close to like what Alex was talking about, is we have to actually start our gain node at 0, have it ramp up very quickly, so our ears can't really process it, but we don't hear that pop click. So I'll code that out so I can demonstrate how parameters work on nodes. So what you can do is our gain node has a gain parameter, which will start it, set value at time. All right, so the set value at time method, you give it a time and a value and sets it. So we're going to start with a very small number and at the time that we want to start this process. Then we are going to exponentially ramp, because that's cooler than linearly ramping. I mean, these are the kinds of methods you work with in the Web Audio API.
Somebody really wrote that.
All right, so we're going to ramp up like very quickly at 0 to 2 seconds. And then you would think at the end, we want to ramp back down to we're doing it time +1. So let's just do time and time +1. Okay, but the way these parameter methods work is that they start their transition from the last scheduled event. So what would happen in this case is that it would immediately start ramping down to 001 right after it hit this peak at time plus 0.02. So we have to set the value again just prior to. So what this should do is just, well, it's pretty close. Time plus, here we go, time plus 0.9.
Now feel free to move.
Yeah, there we go. Okay, so that's like a lot of work just to get a couple boops. All right, so what we'll do is we can start kind of making better decisions about how we're going to do this. It's not that exciting. That's what we just did. Let's go over to our analyzer nodes. All right. So what I've done, we're going to mute it. If I can't figure out why sound's not playing in 30 seconds, remind me that I just muted that. All right, so we could look at it just like a blank pink screen for the next 30 minutes, but that's kind of boring. So instead, I've written a little UI for this so we can kind of see what's going on, and we have knobs that we can mess with. So anywhere that you see something DOM, that's like a little React component that's designed to work with this. Speaking of React, can we get a round of applause for Lon, who had such a rant last month that Facebook changed their license for React? That's pretty great. Good. So one of the nodes that we're not going to get into too much, but will be important, is that there's what's called an analyzer node. It doesn't process audio at all, but it kind of spies on the audio going through it and gives you some information about it in an array that you can then use to do different stuff. In this case, we're going to use it to draw some waveforms. We can look at the time space, which would be the wave over time, or the frequency space. So it kind of gives us a spectrum of all the frequencies going on. So if I refresh this here, I'm going to unmute real quick. Okay. Cool. So that is a sine wave. That is the wave of airplanes and really boring stuff. We'll get into other waves here in a second. Okay, so we've got a little DOM we can work with down here now. Let's go to cooler stuff. All right. So here's the plan. We've got this. And this is like, things could really go wrong here real fast. We're going to try to go section by section. Look at my, oh God, I'm so sorry. You have to look at my hands. We're going to go section by section through this synthesizer that I've got. This is called a microbrute. It's an honest to goodness analog synthesizer, which means all of the waves being generated is electricity going through probably like op amps and stuff. I don't know. I have a degree in electrical engineering. I literally have no idea what's in here. Capacitors probably. So we're gonna learn about synthesizers because I know that's like the most interesting thing that y'all probably the reason you're here, and then try to recreate this in the Web Audio API. So we're gonna start with oscillators, and like I said, the sine wave is a real kind of dark, boring oscillator. It's a waveform so boring that the microbrute doesn't have it because it's too cool for it. So we're going to start with how about this? It's called a sawtooth. You see kind of the shape there. I mean, this is the waveform that you use when you want to get people on the dance floor to like get teary-eyed because it's just like the epic part of your set. Are you feeling it? All right. Yeah. All right. So we've got a sawtooth there. Let's see if we can't recreate that here. I'm going to turn our oscillator down while I unmute it. Let's pick our sawtooth. It's pretty loud. All right. So far, like already there's some really, like I said, weirdly specific stuff that the Web Audio API gives you to build a synthesizer. Pretty great. Can I tell you how close I was to learning what a pointer was? Like I almost wrote a synthesizer in C++, but JavaScript will do it for us. All right, let's do a square wave. So a square wave is a good base. Like you want to fill the bottom end of the room, right? All right, pretty rad. And then we've got the triangle, which is like, it's perfect for, it's a real mellow kind of wave. It's perfect for like the doop-a-doop-doops that go kind of on top of your music. Yeah. All right. I mean, we could just do this for the rest of the talk. It'll be fine. Cool. So we've got some oscillators, but what makes the microbrute cool is that you don't get to work with just one oscillator at a time. You can like mix and match. Bring in the sawtooth. So can we do that with the Web Audio API? And I think it's pretty obvious that, yeah, we just create a bunch of oscillators. So we'll get oscillator 2 and 3, and then we'll come down here, and we'll copy this a couple times. Our live coding is so exciting. 2 and 3. It's going to be really loud. That's this one here. We got to get them all playing at the same time too. Turn this down a little bit. All right, here we go. Those are sines. Let's do our triangle, square, sawtooth. So that's all of them turned on, but let's just kind of mix and match a little bit. Pull the triangle down. Cool. So we've got a little mixer. We can do that. Turn them all down while we talk. right? But we have JavaScript, so we don't need to just copy and paste a bunch of stuff. What we can do is combine them into our own. I know, I made some changes. Yeah, can VS Code do that? Yeah, you tell me. All right, so what we got here is a multi-oscillator. So again, this is more of a Reacty DOM thing, but you can combine all these nodes and kind of patch them into one gain and turn it off. You can mix and match. You got a little mixer here. So already we're pretty far along in our oscillators. Now you'll notice there's all these knobs up here. These are the can web audio? Not really. So we'll talk about these knobs later in our section of the talk. So moving on from oscillators, we have a filter. So the filter is what makes each synthesizer really unique. A lot of synthesizers will give you these knobs here, but the filter is usually implemented differently on each synthesizer, and it's what kind of makes it unique. So a filter will take frequencies and cut them out of the waveform that you're playing. So this is called subtractive synthesis, where you start with a waveform and you take out chunks of it. We've got low pass, which cuts out high frequencies. We have a high pass that cuts out low frequencies, and we have a band pass, which gives you just a range of frequencies in your sound. This resonance knob will, depending on which filter you're on, high pass and low pass, it kind of gives you a peak right at where you're going to cut the remaining frequencies off. And then for band pass, it kind of gives you a width. How many frequencies are you going to allow through? So we can do, this is a low pass filter. So this is fairly high note, so you can tell it cuts it out there. But if we put in something that has a little more harmonics, that's pretty cool. Let's see if we can recreate that sound. We'll switch over to our filter. Oh, we skipped the keyboard. We'll get back to the keyboard in a second. All right, so we've got our filter here. We've got a high pass. Let's switch it to a low pass just to match it, resonance. And we will do, what, a sawtooth? Oh, that's too loud. So you can watch the frequency analyzer there, and you can see how it'll cut out those higher frequencies as you go. Anyway, and that sounds kind of cool. The resonance, when you turn it up, makes like R2D2 noises. Talking wah-wah noises. We can do that too. Not bad. High pass sounds like that, but opposite. I mean, come on, just do this. All right, cool. Let's talk about another important part of this device here, and you can't see it on the screen, but it's like right there. It's the keyboard. Again, I don't know how to play the keyboard, but it's important that it's there. We also have a keyboard, so we can wire it up to kind of act the same way. Let me show you what that looks like real quick. So we just take each of the rows of keys and split them up, and using math, we figure out what notes they're going to play. Turns out an octave is 12 notes. One octave is twice the frequency of the octave before it, and so there's some basic math that'll tell you what note will go in between each one. So on the bottom, we're 2 octaves below the top, which will be our root. And then we trigger notes by anything that's wired up to this keyboard. We trigger a start note, and then that returns its own stop function. So again, because oscillators have to be created and destroyed, you have to kind of keep track of what oscillators are playing. And the way I've chosen to do that is by returning the function that stops it. You could also do it with like an event system. So you dispatch a note start and a note stop event. I've done that. I don't know which one's better. It's the one we're doing tonight. So what that means is, you come over here. Yeah. Like, Freaking dead mouse, right? All right. Is he still a person? Pretty cool. All right. So we've got filters and we've got a keyboard, got a synthesizer. Next is probably my favorite part of the synthesizer, and that is the LFO. So an LFO stands for a low frequency oscillator. And you'll notice it's got waveforms just like our other oscillators. The difference is that it oscillates, its frequency is below audio rate. So most ears will pick up audio around 20 hertz and then goes up to like 20,000 hertz, but this will go much lower than that. And you can use it to modulate other things in this device. So I'm going to grab the patch cable real quick because I don't have it in me. So this is how you wire up a synthesizer. Plug it in. So we're going to use this to modulate. If you can see over there, plugs into our filter. So we pick a depth, like what the gain of this oscillator is going to be, and the rate for it to oscillate at. And then which waveform we want to use. I like the square wave for this. So it's going to modulate our filter here. We'll make it faster. And actually, if you make it, so that's actually audio rate right there. You can tell like you can stop. You can't hear the modulation anymore. You just hear like a tone. You can make it go lower. We can change the waveform. Cool. I mean, don't y'all want to get into this stuff? Don't. It's super expensive, and you should just write your own JavaScript ones. All right, so let's go over it. Let's check out our LFO here. All right, so we've got the LFO. LFO, we do the same. We create a gain node, and then whenever we trigger it, we're going to trigger an oscillator to create an oscillator, and then we wire it up to something. So in our code, what we're going to do is got an LFO, create the LFO. We're going to wire it up to the filter frequency. So it should do a very similar thing here. All right, so we've got a filter now. It's a high pass filter, so we should be able to hear everything. Let's do like that. Here's our LFO that should modulate it. So you can take the depth way up. You can get up pretty high too with that. Or square wave. That's it. It's amazing. All right, so let's see. We've got LFOs, we've got filters. Next up, we have this envelope. You probably can't see too well because of the glare. So an envelope, they call these ADSR. So it stands for attack, decay, sustain, and release. So what we've been listening to so far would be a very quick attack, solid sustain, and a very quick release. But with an envelope, we can change how quickly our amplitude ramps up, how quickly it falls off, and then what happens when we let go. So if we have a very high attack, yeah, I know. Okay. The sustain is the volume that it's going to stay at. So we can have it ramp up and then drop off. Decay is how long it takes to get from the peak down to the sustain. We can be very quick. And then release is what happens when you let go of the key. I love a good release. Like the release is just like, and it's that saw wave. You can't feel that? All right. So this is where the Web Audio API starts running into some of its limitations, because in order to do an ADSR envelope, the oscillator needs to know about how long things like the release are going to be. Because if you tell the oscillator to stop before the release is done, that's where you get that kind of weird clicky poppy noise. So we'll just look at some quick code, but we'll get to playing around with it. So we define an AD, S, and R, so very quick, solid, sustain, very quick release. And the way I've done it is you basically add parameters to it, and then it's responsible for calling all those set value, exponential ramp, and things like that on the parameter you pass in. So for our oscillator, pass in the ADSR, and then you wire it up and you trigger it, and then when you stop the note, you have to know, again, how long that sustain is going to be so that the note doesn't stop too soon before the envelope stops, ramps back down. All right, so we've added it to our multi-oscillator here. Here's normal. Okay. Kind of swell, you know, if you had a chord going on. Right? Okay, or we can have a very long release. I think that was called a minor key. All right, if we want to cut the sustain down, you can hear it kind of cut volume. Okay, cool. So we are most of the way through our synthesizer so far. Doing pretty good. There's another part, though, that is very important to me, which is the sequencer. And it's going to be kind of hard to see here. The sequencer is important because if you don't know how to play music, you can just program it, and it plays it for you. So the way you might do that is you just pick some notes. Right? So then your hands are free. And this is why I got into synthesizers, so I could just twiddle knobs. There's a sub-oscillator, right? Okay, so can we do that in the Web Audio API? Yes, we can, but it's complicated. In order to do it in the Web Audio API, we need two things. We need a clock, which tells us what tempo we're going to go at, and the clock runs with set interval or set timeout. And what we know about set interval and set timeout is that they're super unreliable, and you can't use them to schedule audio events, and they're just bad. You shouldn't use them for stuff. So what we do is we use that to then schedule notes to be played on our oscillators. And again, it's complicated. I barely understand how it works. But you basically say, all right, how fast are we going? How many times do we want to do a tick per beat? And then we're going to, anything that's sort of registered to listen to those is going to get the notification about exactly which time to play. And so what we register to that is called a sequencer. And we give it some steps to play. This is more math. You give it like a root note, and then how many semitones to go, and it'll just figure out which frequency to play. So the sequencer gets the note on event, basically, schedules it to play that, and steps through that array. So let's see what that looks like. All right, here we go. We got our clock playing at 120 beats per minute, and here's our sequencer. The gate is how much time in between each beat it's going to have that sustain for. So this would be like sustain the whole beat, and then this is going to be just for a real brief time. So like I didn't have to play anything. I just wrote down some numbers and it worked. Okay. I mean that's our sequencer, our synthesizer pretty much, but we don't have to stop there. No, you probably could. But the idea is that you have it running just far enough ahead to schedule notes in case like there is a hiccup in your UI thread, and then but not so far ahead that if you hit the stop button, it wouldn't like, because you can schedule notes out, a year for a year. It's just if you hit stop, then you're sort of stuck with that boop, boop for the whole time. So you could probably use request animation frame. I don't know if it buys you a whole lot though, because you still have to get into the context time to do anything with the notes. So, okay. So one thing you might notice is the whole time I'm doing this, the secret is synthesizers actually sound kind of dry. Like they're not that great out of the box, which is why we have effects pedals. And big shout out to Alex for letting me borrow his analog delay pedal. So an effects pedal is basically an effects node for our synthesizer. So oh, it's beautiful, right? Like if we stop it, kind of hear the hear that? Like it just adds life to, I mean, I love this machine, but it needs a little life. All right, we're just gonna listen to this for a second. All right. Can we add a delay? Yes, we can, because there is a delay node, like, again, oddly specific thing that we might need to build a synthesizer. So the delay node I built has a mix, it has the time, and the feedback, which is the delayed node by itself just offsets the signal coming in by a certain amount of time. So if you want it to kind of get that where it kind of trails off, you add another gain node and have it feedback on itself, and then it'll sort of over time drop off. So let's give a low release. Like, it's perfect. It's cool. What other nodes do we get? Turns out we get a distortion node. I have a distortion pedal, but it actually is the worst pedal ever and is full of a lot of noise even when it's not turned on, so it's not hooked up. But here we've got it hooked up here. Distortion is what you might think it sounds like. It's called a wave shaper. It takes the wave coming in and crunches it. Sort of sound, I mean, it sounds a little bit like it's just boosting the volume, but it actually is shaping the node to clip off the edges. I mean, that was pretty punk rock, right? Let's see. Yeah. Cool. All right. So that's basically how you can rebuild this with the Web Audio API. But we've got a few more minutes, so let's see what else we can do. Let's build some synthesizers that aren't this. I've got one here called the detune synth, and the way it works is I've got 3 oscillators that play, and y'all just tell me if I don't have a few more minutes.
You do have a few more minutes.
All right.
Minutes.
Yeah. All right. Because I mean, this is really where it just like peaks. There it is. That's that sawtooth I was telling you about. This is like, you feel it, just going. So that's 3 different oscillators that are playing the same note, but they are detuned from each other a little bit, and that really is that sort of dead mousey, like whenever you get big, powerful parts of your music. Yes, what a great idea. Oh no, I can't. It's not wired up here. We'll get there. We'll get there. Let's keep going. Let's power through this. Now detune. What if we have more than one sequencer? Got a clock. We've got a mixer. Why? And I'll be honest. This is why I got into it, because you can have music just make itself and sit there and code and not have to worry about, like, you don't want to make music too good that you want to listen to. You just want music that's kind of going on in the background. It's cool. So that's hard-coded sequence, but I told you we were going to get, if you read the description, we're going to get to aleatoric music, which is music that it has some randomness to it. And it goes way back to like Mozart invented a dice game is what the story is. You like roll the dice and that's how you decide what your composition is going to be. So what we're going to do is instead of hard coding some sequences, we're just going to have it build sequences for us. See how this goes. It's very quiet. There's the distortion. Hear that going? Pretty cool. Every time you refresh, it's gonna be like just a different tune. It's no problem. It's cool. Sorry, we got one more. So we can just mix it. There's that detuned synth going into a delay for you. That was great. Now what would be really cool is if you had like used the sampler, the audio buffer stuff to do like a drum machine, or if you're like me, you carry around a techno calculator. Right? Just keep going. Oh, we got way off here on the tempo. All right, we're back. It's good. All right. All right, that was the performance part of the talk. All right, let's go back. Let's blow through this. The good stuff about Web Audio API is it gives you like all the building blocks you need to build a synthesizer. It's awesome. It's easy to get started. The API is not that complicated to get into. There's some good resources on it, and it's fun. Like that was a blast putting together. Yeah, scheduling events is hard. Once you schedule them, you can cancel them, but you can't modify them. So doing envelopes that you want to re-trigger and change in the like as you play, almost impossible to do. Moving from the JS space to the web audio space is difficult. Some of those knobs are not able to be controlled with the audio parameters by connecting other nodes because they're just JavaScript React stuff. It'd be great if there was an easier way to control JS with web audio code. There's a lot of stuff like these knobs up here that I was talking about that are really cool. They like change your sound. And you just don't. They're all done with shifting the phase of the wave. That means it starts or stops slightly off from what would normally be considered the start of the wave. And that's when they interact together, that's where you get some of those cool sounds. DC offsets are another thing. All the oscillators oscillate around 0. So if you're going to use it to modulate like volume or the gain, you can't say only modulate from 0 to 1. It's going to modulate from -1 to 1 or whatever you. It's kind of frustrating if you're trying to like have something fade out and fade in. And then finally, audio workers. They used to have JavaScript nodes, so you could use JavaScript to process audio. Turns out, bad idea. It just doesn't. You get too much latency and it doesn't work. So they back in 2014, they deprecated script processor nodes, and the new node is going to be audio worker nodes. And when you click on audio worker nodes, you get this is MDN right here. Like literally, no browser has implemented them in 3 years. So good luck. Good news is there are people who have figured a lot of this stuff out. Tone.js is a super solid framework that accounts for a lot of those things that I just said, whereas LiveJS.network, a great group of people who do shows at like JSConf and things like that using web audio and stuff. And Google, there are so many demos of this. I mean, it was Most of the demos are from 2015, like when web audio was cool. But there's a lot of good resources out there. So right on time. We'll have questions, I guess, after this, maybe, if you have questions. But still talk. We can go back to Lon to come in.
Let's take it like 5.
I'm just going to leave this point.
JK.
DJ JK? No. That was a one-time thing.
Well, I know 2-time thing.
Now it's a 2-time thing.
So let's take 5 minutes,
Cool.
come back and do some questions, and we'll have a good debate after that.
Awesome. Thanks, y'all.